Hello all, today we are going to take a look at one of the hardest problems in my opinion in CS50 Introduction to Databases with SQL, which is Moneyball. First of all, each problem, you should read this segment here to know what you're gonna do in this problem. Here basically you're just gonna create a baseball team depending on a database you are provided with. And you should download this distribution code in your Visual Studio here. I already did this, just do it and you will get a folder called Moneyball. Within it you have 12 files and your database. So we're gonna write 12 SQL query. Let's get back to our problem. Let's see the schema of our database. We have 4 tables, and this is the ER diagram of our schema. We have the player table connected to the salary table in one-to-many relationship, and player table is connected to the performance table, then performance is connected to team table, then team table is connected to salary table. You should really care about this ER diagram to understand how are your tables connected within your database. And we can see here, we can see that columns within each table. This is the players table, teams table, performances table, and lastly the salaries table. And now let's get started by writing our very first query. Okay, you should start by getting a sense for how average player salaries have changed over time. In one data SQL, write a SQL query to find the average player salary by year. Sort by year in descending order, round the salary to 2 decimal places and call the column average salary. Your query should return a table with 2 columns, one for year and one for average salary. So basically we just need 2 columns. We need column for every single year, and we need the average salary for every single year. Let's get back to our Visual Studio Code. Let's start writing our query. Select year and also salary from, we can find those both tables in our salaries table. So salaries, where let's get back to see what we're gonna do. The average player salary, so we should use the average aggregate function, and because we need to every single year, not just the same average for all years, should use the group by keyword. Group by year, because we need the average salary for every single year. And we also want to sort it by year. So order by year in descending order. Yeah. Okay, just let me fix this. Okay, and we need to round it to 2 decimal places. Should use round to And that's it for the first one. Let's check it. Let's go to our Moneyball directory. Let's open our database. Let's run this file. And as you can see, we have every single year sorted in descending order and their average salary. I think we should call it average salary as average salary. And we are done. Let's see the second one. Your general manager asks whether the team should trade a current player for Carl Ripken, a star player who's likely nearing his retirement, and to the skill right SQL query to find Carl Ripken's junior salary history sorted by year. Sending order your query should return a table with two columns, one for year and one for salary. Before we start this problem, I just want to give you a look at something called SQL query order of execution. I just want you to know, and when you see a complex query and you don't know which clause is gonna execute first, here is the order. From is gonna execute first, then where, group by, having, select, order by, and then limit. Let's get back to our query. Okay. So we need to know the year and salary, which is the history of Carl Ripken. But here we have to join two tables together. One is the salaries table and the other is players table. So let's get back here and start writing our query. Select year salary from salaries. Not just that, we need to join the players table. Join players table on players dot id equal salaries dot player id, where first name is Carl and last name is Ripken. We need to order this query by year in descending order. Let's test our query here. And as you can see, we get back the correct results. Let's get back to see the rest of queries. Actually, number 3 and 4 and 5 are pretty similar to what we did in number 2. I'm not gonna do it, but I just wanted to show it to you. This is number 3, this is number 4, and this is number 5. If you have any question regarding those queries, just ask me there, ask me in the comments. Now let's see the sixth one. Here, as you can see, which teams might be the biggest competition for the A's this year. And 60 SQL at SQL query to return the top 5 teams sorted by the total number of hits by players in 2001. Call the column representing total hits by players in 2001, total hits. Sort by total hits, highest to lowest. Your query should return 2 columns, one for the team's names and one for the total hits in 2001. Here we are gonna use 2 tables. One is the teams table and the other is performances table. Let's get back to our Visual Studio Code. Okay, let's begin writing our SQL query. Select name, which is the name of the team. We need the total number of hits for every team. So we need to use this aggregate function called sum. Let's see what what is hits called in the performances table. It's called h. Okay. So we write h. We need to change this column name to total hits. Total hits from teams we need to join the performances table. Performances on ID, team ID, performances dot team ID equal team's ID. We need this for the year 2001, as you can see here. So we're gonna use where performances dot year equal 2001. We need to group by team ID. Why? Because H in the performances table represent the total hits by one player in every single year, and we need the total hits by the whole team. So, as you can know, the team has multiple players, so we need to group by performances dot team ID. We need to order the results by the total hits, the most to lowest, highest to lowest. So order by total hits. In descending order, of course, because it is from highest to lowest. And we only want the top 5 teams, so limit 5. Let's run our query. And here we go. This is the results. Let's see. For number 7, it's actually pretty easy. I'm just gonna show you the code of this one. Here it is. And now let's see the rest of the queries. Now let's see number 8. How much would the A's need to pay to get the best home run hitter this past season? In it, does QR write a SQL query to find the 2001 salary of the player who hit the most home runs in 2001? Your query should return a table with one column, the salary of the player. Here we are gonna use three tables. Why? We need the salary, so we are gonna use the salaries table. We need the hit, which is in the performances table, and also if you can see that the performance table and the salary table is not are not connected directly. So we need to use something like the player table or the team table. So I'm gonna use the player table here. So let's get back to our Visual Studio Code. Let's go here. So we need the salary. Select of select salary from, let's say, performances. We are gonna join all the three tables together. Performances, join. We first need to join it to the players table. Players on players dot id equal performances dot player id. And now we are ready to join this table to the salaries table. On salaries dot player id equal players dot id. Okay, where we want the year to be 2001, where salaries dot year equal 2001. We actually can't use the year inside the performances table because we are joining these three tables on ID. So that doesn't mean that the year inside the salary table is corresponding to the year inside the performances table. We can't assure that. And we need to order this by performances 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 mm, HR, which is the player's number of home runs. Performances dot HR in descending order. Limit by 1. Let's run this query. Dot read it dot SQL. Parse error, no such table performances. We spell it wrong. Perform- Performance, form, performances, like this. Okay, let's run it again. Players.id, players.id. Okay, here should be equal players.id. Let's run it again. And as you can see here it is the results. Let's see the next one. What salaries are other teams paying? 9. To write SQL query to find the 5 lowest paying teams by average salary in 2001. Run the average salary column to 2. Decimal place and call it average salary. Sort the teams by average salary, least to greatest. Your query should return a table with 2 columns, one of the team's names and one for their average salary. This query is also similar to what we did in the previous ones, so I'm just gonna show it to you. Here it is, just joining one table, and it seems to be pretty simple. And now we're down to the last 3, and these actually are the hardest 3 queries in this problem. Let's start by number 10. Here, the general manager has asked you for a report which details each player's name, their salary for each year they've been playing, and their number of home runs for each year they have been playing. To be precise, the table should include all players' first names, all players' last names, all players' salaries, all players' home runs, the year in which the player was paid that salary and hit those home runs. So we're gonna use 3 tables: salaries table, performances table, and players table. In 10, .scale write a query to return just such a table. Your query should return a table with 5 columns, per the above, those 5 columns. Order the results first and foremost by player's ID, least to greatest, which is ascending order. Order rows above the same player by year in descending order. We may have the same player twice, so we are gonna order it in descending order by year. Consider a corner case. Suppose a player has multiple salaries or performances for a given year. Order them first by number of home runs in descending order, followed by salary in descending order. Be careful to ensure that for a single row the salaries year and the performances year match. Let's see this example table. We have 5 columns. If we have the same player name, we're gonna sort it by the year. First we're gonna sort it by IDs, then we're gonna sort it by year in descending order. Okay. Let's get started. Let's get started. Okay, let's get started. Let's open this. Let's write our query. We need 5 columns, so select. And we need the salary column. We need the salary, I mean. And also we need the first and last name. First name and last name, and also we need the home runs. Home runs. Let's see what does it called. HR. And the year of performance. So performances dot year. We need to try this namespace like that. We can't just say year because the salaries table has also a year column. So our SQL query wouldn't know which one we mean. From performances, and let's join the two other tables. Let's join the players table first because there is no direct relation between performances and salaries table. Players on players dot id equal performances player id. Performances dot player id. And let's join the salaries table. Salaries on. Here we're gonna add, like, we are gonna join on two things, not just the ID, but also the year, performances year and salaries year. Because if we didn't do that, performances year and salaries year wouldn't be the same in the same row. We may have in the same row the salary year like 1999, but the performances year is 1989, for example. So let's start with the IDs. Salaries ID, salaries player ID, player ID equal players.id, and also performances year equal salaries year. Performances year equal salaries year dot year. Okay, and now we need to order the results. Order by players ID. Players ID. And what else? Let's get back. ID, then the year in descending order, then order first by number of home runs in descending order, followed by salary in descending order. Okay. Salaries year in descending order, and home runs in descending order, and lastly by salary. descending order, and that's it. Let's test our query. .SQL. I know such column. I spelled it wrong again. Let's see where here. Players players.id. Okay, let's again players.id, just where here. Players.id. And we need to check if these are the correct results. Let's get back here. As you can see, we should have 14,915 rows. So we can run this in our terminal to be sure. Let's quit and copy paste this. File name is 10.sql. .sql. Let's see the output. Let's see how many rows we have. 14,9,000. Almost 15, because there are rows that doesn't have any data. Okay, let's see the next one. Here you need a player that can get hits, who might be the most underrated. In 11.SQL query to find the 10 least expensive players per hit in 2001. The query should return a table with 3 columns, one for player's first name, and one for their last names, and one called dollars per hit. You can calculate the dollars per hit column by dividing a player's 2001 salary by the number of hits they made 2001. Recall you can use as to rename a column. Divide salary by 0 hits. Where dividing a salary by 0 hits will result in a null value. Avoid the issue by filtering out players with 0 hits. Sort the table by the dollars per hit column. List most expensive if 2 players have the same dollars per hit. Order by first name followed by last name in alphabetical order. As in 10.SQL, ensure that seller's name and performance's name year match. You may assume for simplicity that a player will only have one salary and one performance in 2001. Let's open this one and start writing our query. We need 3 columns here. First name, last name, and salary dividing by let's see, dollars per hit. Dollars per hit is okay. Okay. Salary dividing by, what does it call in the performances table? Number of hits, H, okay. H as dollars per hit. Dollars per hit from performances. Let's join the two other tables, which are players and salaries. Let's just copy and paste them from the last query. Just copy and paste. Okay. Now where performances.year is 2001, and also we need to avoid the players were with 0 hits. So, and hatch more than 0, order by dollars per hit, and then by first name and then the last name. We need just, I think, the top 10 or something like that. We find the 10 least expensive. It's just the 10 least expensive, so limit 10. Simple. Let's open our database again. SQL, and here we go. We got our results. Okay, let's get back here. Hits are great, but so are RPIs. In total, DataSQL writes SQL query to find the players among the 10 least expensive players per hit. Among the 10 least expensive players per RPI in 2001. So seems like we are gonna write to, we are gonna use the intersect keyword somewhere here. Let's continue. Your query should return a table with 2 columns, one for player's first name and one for their last name. You can calculate a player's salary, their RBI, by dividing their 2001 salary by their number of RBIs in 2001. You may assume for simplicity that a player will only have one salary and one performance in 2001. Order your results by player ID, least to greatest, or alphabetically by last name, as both are the same in this case. Keep in mind the lessons you've learned in 10.skill and 11.sql. So we should first get the 10 least expensive per hit, and then get the 10 least expensive players per RBI and use intersect between those two tables. Okay, let's get back here. Let's start by getting the 10 least expensive players per hit. Select first name, last name, and let's also select the ID, because we want to order by the player ID. But we just gonna you choose the first name and last name in the final results. Players dot ID. Let's call it just ID for simplicity. And let's do from performances. Let's join the two other tables. Join first players table on players ID equal performances player ID. Performances player ID. And let's join the salaries table. Let's just copy and paste it from here. We are gonna use this same line. Okay, and now let's put our condition. We only wanted where performance year is 2001. We can also copy and paste it, I think, from here. Yeah. And also we need it for this, if you remember, for players per hit, we need it for the hits where the hit is more than 0, so we don't get back a null value. Okay. And now let's do the same for the RBI. Let's copy and paste this. Let's first order this results. Order by salary divided by match. Okay, we need only 10 results. Limit 10. And let's do the same for RPIs. Let's leave some spaces for the intersect keyword. Okay, first name, last name, player's ID from performances, join players table, join the salaries table, where performance is year 2001, and RBI. RBI is more than 0, and let's divide salary by RBI. And now we can't actually just use intersect like this. Intersect. We can't use it because we should use intersect only between two select. But here we are using it between order by. Order by should always be in the last. So let's wrap our two queries with a select statement. Select clause, excuse me. Select first name and last name and ID, not player's ID. An ID from all of this. And let's do the same for the hits table. Let's put this parenthesis. Okay, now we can use intersect, but if you can remember, we only need two columns. Players, one for the player's first name and the other for their last names. But after this intersect, we are gonna have three tables: first name, last name, and ID. Let's wrap all this with a select clause. Let's write here select first name and last name only. Do we need to order the results? Order the results by player ID. Okay, let's order the results by ID. Let's put semicolon here. Let's see if this actually works. We have a syntax error. Let's add some space here. Let's see. And now we also have a syntax error. Okay, seems like we forgot to write the from clause right here. And let's run the square again. Finally, here we go. Let's use check 50. And yeah, let's use check 50 here and see the results. And actually, I realized that there was an error in the query number 4 here. This is how we should write it. Sorry for the mistake. And seems like we have some error in SQL number 10 here. Okay, seems like I forgot a comma here. Now everything should work. Let's run check 50 again and see the final results. Let's wait, and I hope it works now. And finally, here we go. All of them are correct. Thanks for watching.